Given y equals 20 minus 1/4 times the quantity 5 minus 3x to the fourth, find dy dx. All right, so here we have two terms. The first term is a constant, so the derivative of a constant is 0. So when we start to write out dy dx, again, we're going to start out with 0. And then here, the derivative is going to require the chain rule. So we're going to go ahead and bring this 4 to the front and multiply it by the negative 1/4 that's already there. So 4 times negative 1/4 is negative 1. So we're going to have negative. And then 5 minus 3x all raised to the third power. So we're doing the derivative of the outside, leave the inside alone, times the derivative of the inside. So the derivative of 5 minus 3x is just 0. And then I'm going to have the derivative of negative 3x is negative 3. So just negative 3. And so we'll multiply the negative 1 times the negative 3. So we have a final answer of 3 times the quantity 5 minus 3x, all raised to the third power. Now let's find the derivative with respect to x of the square root of the quantity 3x squared minus 4. I'm going to start by rewriting this as the derivative with respect to x of the quantity 3x squared minus 4 to the 1/2 power. So now this is a chain rule. The outside function is that square root of x. So I'm going to bring that 1/2 to the front. So notice I'm not writing the operator anymore because I'm about to take the derivative. So 1/2, leave the inside the same, 3x squared minus 4, to the negative 1/2. So I'm subtracting 1. I'm doing the power rule on the outside, leaving the inside the same, and then times the derivative of the inside, which is just by the power rule, 6x. Now let's simplify this a little. 6 times 1/2 is 3, so I'm going to have 3x. And that's going to be in the numerator because the quantity 3x squared minus 4, that's raised to a negative exponent. So I'm going to bring that down to the denominator, the other side of the fraction bar, to make it a positive exponent, which really will turn it back into a square root. So when I bring this to the denominator, it's going to be the square root of 3x squared minus 4. So this is my answer. Given f of x is equal to the quantity 1 plus 2x to the 3/5, all raised to the 5/3, find f prime of x. So here, this is another chain rule. We're going to start by taking the derivative of that outside function. So we're going to say that f prime of x, the derivative, is 5/3. And then we have the quantity 1 plus 2x to the 3/5. Then I have to subtract 1 from 5/3. So if I subtract 1, that's subtracting 3/3. So I would have 2/3 left. And then I have to multiply by the derivative of the inside. So the derivative of the inside here, the derivative of 1 is 0, but here 2x to the 3/5, that's a power rule. So we'd have bringing that 3/5 to the front and multiplying it by 2, that's 6/5. And then x, well, if I subtract 1 from 3/5, if I subtract 5/5, I'm going to have negative 2/5. So all of this is all one big term. So let's try to simplify what's going on here. So I have 5/5. So the 5/5 is going to cancel and just give me a 1 there. Then I have 6 divided by 3. So that's going to leave me with a 2 in the numerator. And the x to the negative 2/5, that's going to move down to the denominator. So let's rewrite this. Let's keep that 2 in the numerator. And then this entire quantity is raised to a positive exponent, so that'll stay in the numerator. 1 plus 2x to the 3/5, all of that to the 2/3, and then all over x to the positive 2/5. So I'm going to bring that down to the bottom and make it a positive exponent. So this is my final answer.